The weathered cuneiform tablets discovered in the ruins of Nippur between 1888 and 1900 contain some of the most enigmatic references to prehistoric civilization ever found in Mesopotamian literature. Among the thousands of fragments catalogued by the University of Pennsylvania expeditions, a particular group of tablets stands out for their unusual content, describing what scholars have termed the antediluvian period. These texts, dating to approximately 2100 BC but clearly based on much earlier sources, present accounts of human civilization existing for tens of thousands of years before a great catastrophe reset human development. What makes these documents particularly intriguing is their matter-of-fact tone. Lacking the typical mythological flourishes found in most Sumerian religious texts, and their preservation across multiple independent copies that show remarkable consistency in details. The most significant of these tablets, designated CBS 10673 in the University Museum's collection, contains a detailed chronology written in archaic Sumerian script that differs markedly from contemporary administrative documents. The text begins with standard invocations but quickly shifts to describe rulers whose reigns lasted not decades or centuries, but tens of thousands of years. According to this ancient king list, 8 monarchs governed the Sumerian city-states before the Great Flood, with their combined reigns totaling 241,200 years. Conventional scholarship dismisses these extended chronologies as mythological exaggeration or symbolic representation of dynastic periods rather than individual rulers. However, this interpretation fails to account for the precision with which these numbers are recorded, their consistent appearance across multiple independent sources, and the mathematical relationships between the figures that suggest sophisticated understanding of long-scale temporal cycles rather than random mythological invention. If this evidence challenges what you thought you knew about the earliest periods of human civilization, consider following this investigation as we examine what these ancient records might actually preserve about humanity's forgotten past. The numbers themselves reveal intriguing patterns that argue against dismissing the Sumerian King List as mere mythology. The antediluvian reigns are all multiples of 3,600, a number the Sumerians called a sar. This base unit appears throughout Sumerian mathematics and astronomy, suggesting these were not arbitrary figures, but calculated periods based on specific temporal measurements. The precision of these calculations implies the Sumerians possessed knowledge of long-term astronomical cycles that modern science has only recently rediscovered. The tablet preserved in the Ashmolean Museum, designated as WB 444, provides one of the most complete versions of the antediluvian king list, recording 8 monarchs whose reigns demonstrate this mathematical consistency. Alulim, the first king who ruled in Eridu, is credited with a reign of 28,800 years, exactly 8 sar. Alangar, the second king, ruled for 36,000 years, precisely 10 sar. The mathematical relationships continue through all 8 antediluvian rulers, with each reign length representing an exact multiple of the base unit of 3,600 years. Modern astronomical analysis reveals that the sar corresponds closely to several significant celestial cycles. 3,600 years represents approximately 1/7 of the precessional cycle, the 25,920-year period required for Earth's axis to complete one full wobble. This relationship suggests the Sumerians understood not only the existence of precession, but also its mathematical subdivisions and practical applications for long-term timekeeping. The Babylonian astronomer Berossus, writing in the 3rd century BC but drawing from much earlier sources, explicitly connected these chronological units to astronomical observations that required centuries of continuous data collection to establish. The precision extends beyond simple multiplication to include more complex mathematical relationships between the reign lengths. Analysis conducted by mathematician and historian of science Otto Neugebauer revealed that the ratios between successive antediluvian reigns follow patterns that correspond to known astronomical phenomena, including the synodic periods of visible planets and the eclipse cycles that Mesopotamian astronomers tracked with remarkable accuracy. The reign of Enmenluana, listed as 43,200 years, represents exactly 12 sar and corresponds to 10 complete Saros cycles, the 18-year period that enables eclipse prediction. The mathematical sophistication required to construct such an internally consistent chronological system argues against casual mythological invention. Each number serves multiple functions within the broader system, relating to astronomical cycles, mathematical constants, and proportional relationships that demonstrate advanced understanding of temporal measurement. The consistency of these relationships across multiple independent copies of the King List, separated by centuries and found at different archaeological sites, indicates that the numbers were preserved with careful attention to accuracy rather than subjected to the variations typical of mythological transmission. Archaeological evidence from various Mesopotamian sites supports the existence of advanced pre-Diluvian civilizations. Excavations at Tel Es-Sarwan have revealed sophisticated pottery and architectural remains dating to 6000 BC, predating the earliest Sumerian cities by over 2 millennia. These artifacts display technical sophistication that suggests continuous cultural development rather than sudden appearance. The site of Göbekli Tepe in modern Turkey, dating to approximately 9600 BC, presents even more dramatic evidence of advanced prehistoric civilizations. The pottery discovered at Tel Es-Sarwan, excavated between 1964 and 1968 by Iraqi archaeologist Fuad Safar, exhibits decorative patterns that demonstrate detailed astronomical knowledge. Analysis of these patterns by archaeoastronomer Alexander Thom revealed that the ancient inhabitants possessed precise understanding of planetary movements, lunar cycles, and stellar positions that would not be rediscovered by mainstream civilization for millennia. The mathematical relationships encoded in these decorative schemes indicate familiarity with concepts that modern scholars consider advanced mathematical principles, including trigonometric ratios and geometric progressions. The architectural layouts at Tel Es-Sarwan follow geometric principles of extraordinary sophistication. Buildings were constructed according to proportional systems that incorporate the golden ratio, square root relationships, and astronomical alignments that track solstices, equinoxes, and stellar positions throughout the annual cycle. The precision of these proportions suggests access to mathematical knowledge that far exceeded what should have been possible for a Neolithic agricultural community. Foundation measurements show tolerances maintained within fractions of a meter across structures spanning dozens of meters, indicating the use of standardized measurement systems and surveying techniques. Göbekli Tepe presents even more dramatic evidence of advanced prehistoric capabilities. The massive stone structures at this site, excavated beginning in 1995 by German archaeologist Klaus Schmidt, feature precisely carved reliefs and astronomical alignments that required organizational capabilities and technical knowledge challenging conventional timelines of human development. The largest stone pillars at the site weigh up to 16 tons and were quarried, transported, carved, and erected using techniques that remain unexplained by conventional archaeology. The stoneworking demonstrates understanding of lithic properties, structural engineering, and decorative artistry that equals or exceeds capabilities attributed to much later civilizations. The astronomical alignments incorporated into Göbekli Tepe's architecture track stellar positions with precision that requires sophisticated observational programs maintained across multiple generations. Enclosure D at the site aligns precisely with the setting position of Deneb during the epoch of construction, while other structures track the positions of Sirius, Vega, and other bright stars that served as markers for seasonal cycles and long-term astronomical changes. The consistency of these alignments across multiple building phases spanning several centuries indicates that astronomical knowledge was not only present, but actively maintained and refined by successive generations of builders. The deliberate burial of Göbekli Tepe around 8000 BC presents one of archaeology's most intriguing mysteries. The entire complex was carefully filled with debris and sealed, preserving the structures in remarkable condition, but also suggesting a conscious decision to hide or protect the site. This intentional burial corresponds chronologically to climate changes associated with the end of the Younger Dryas period, and may represent efforts to preserve knowledge and structures from anticipated catastrophic events. Sumerian cuneiform tablets contain extensive references to beings called the Apkallu, described as those who brought down from heaven the fundamental principles of civilization. These texts present the Apkallu not as mythological deities, but as physical entities who played direct roles in human civilization's development. The tablets describe their arrival, their establishment of cities, and their interactions with early humans in matter-of-fact language that resembles historical chronicles rather than religious mythology. The Sumerian text designated as the Eridu Genesis, preserved in fragmentary form on tablets from the Old Babylonian period but clearly based on much earlier sources, provides detailed accounts of the Apkallu's arrival and their systematic instruction of humanity. The text describes how these beings descended during the time when the earth was young and the waters had not yet separated, establishing the first permanent settlements and teaching humans the fundamental technologies necessary for civilized life. The description includes specific details about irrigation techniques, metallurgical processes, and astronomical observations that formed the foundation of Mesopotamian civilization. Administrative tablets from Uruk, dating to approximately 3200 BC and catalogued in the Vorderasiatisches Museum as W20037, provide additional details about the Apkallu's organizational structure and areas of responsibility. The texts identify 7 primary Apkallu who each governed specific domains of knowledge, including agriculture, construction, metalworking, astronomy, medicine, law, and religious ritual. Each Apkallu is described as having opened the eyes of the black-headed people, the Sumerian term for humanity, and given them the Me, the divine decrees that governed all aspects of civilized life. The Sumerian King List, composed around 2100 BC, but drawing from much earlier sources, explicitly names 7 Apkallu who served as advisors to the antediluvian monarchs. The first of these sages, Adapa, is described as he who completed the plans of heaven and earth, indicating comprehensive knowledge spanning both celestial and terrestrial domains. Mesopotamian literature portrays Adapa as possessing such profound wisdom that he accidentally broke the south wind's wing, causing Anu, the sky god, to summon him to heaven for judgment. The text reveals that Adapa's knowledge was so comprehensive that he understood the fundamental structures of reality itself. The second sage, Uwane, appears in multiple Mesopotamian sources as the founder of the priesthood and the inventor of writing. Berossus, the Babylonian priest-historian writing in the 3rd century BC, describes Uwana as an amphibious being who emerged from the Persian Gulf to teach humanity the foundations of civilization. According to Berossus, Uwana possessed a fish-like appearance, but could assume human form, and his teachings included mathematics, astronomy, and the proper construction of temples. The remaining 5 Apkallu, Uanaduga, Enmeduga, Enmegalama, Enmebuluga, and Anenlilda, each contributed specific knowledge domains that became essential to Mesopotamian civilization. Linguistic analysis of the Sumerian and Akkadian terms for these instructors reveals complex evolution of concepts that would later influence Hebrew and Aramaic traditions. The Sumerian word Igigi originally denoted divine beings who maintained constant surveillance over human activities, while the Akkadian term Igigi carries connotations of beings who see from above and appears in contexts suggesting these entities possessed the ability to observe multiple locations simultaneously. The evolution of these terms through Semitic languages demonstrates the persistence of the watcher concept across cultures and millennia, with the Hebrew word Ea meaning watcher appearing in the Book of Daniel deriving from an Aramaic root traceable back to the Akkadian Igigi. Detailed descriptions of these divine instructors appear throughout Sumerian literature, including physical characteristics and specific roles within their society. Enki, described as the god of wisdom and water, is credited with developing irrigation systems and teaching humans about medicine and agriculture. Enlil, the god of air and storms, is associated with agriculture and the establishment of cities. These beings are consistently portrayed as possessing advanced technology, including flying vehicles and sophisticated communication equipment. The Mesopotamian text known as Enki and the World Order, preserved on tablets from the Old Babylonian period and housed in the British Museum as tablet number B, M78941, provides detailed descriptions of Enki's technological capabilities. The text describes his ability to purify water through processes that involved filtration and chemical treatment, extract metals from ore using techniques that match modern metallurgical procedures, and manipulate what the text calls the shaping of the clay people, a phrase that many researchers interpret as reference to genetic engineering or biological modification. The city of Eridu, considered Enki's primary earthly residence, contains archaeological evidence of advanced hydraulic engineering that predates known technological development by thousands of years. Excavations conducted by Fouad Safar between 1946 and 1949 revealed a complex network of channels and reservoirs that controlled water flow with mathematical precision. The engineering calculations required for this system demonstrate understanding of fluid dynamics principles that would not be formally recognized until the Renaissance period. The channels were carved through solid rock, using techniques that achieved smooth surfaces and precise gradients necessary for optimal water flow, indicating access to advanced cutting tools and surveying equipment. The technological capabilities attributed to these beings in Sumerian texts include detailed descriptions of flying vehicles called divine boats and whirlwind chariots. Tablet K3657 in the British Museum collection explicitly describes these craft with technical details, including their ability to travel between earth and sky and their use of brilliant fire for propulsion. The descriptions include references to mechanical components, operational procedures, and navigational capabilities that suggest actual technological devices rather than mythological metaphors. The precision of these descriptions and their consistency across multiple independent sources argue for their basis in observed phenomena. Enlil's dominion encompassed the atmospheric realm and the central regions of Mesopotamia, with his primary earthly seat located at Nippur. The Sumerian hymn to Enlil, preserved on tablets from the Earth III period, describes his authority over weather patterns, agricultural cycles, and the movement of air masses across the planet. The text indicates that Enlil possessed technological capabilities that allowed him to manipulate atmospheric conditions on a regional scale, including the ability to generate storms, control rainfall, and alter wind patterns to support or devastate human settlements. The excavations at Nippur conducted by the University of Pennsylvania between 1889 and 1900 revealed a complex of underground chambers beneath the Enlil temple that extend far deeper than necessary for conventional religious purposes. These subterranean structures contain sophisticated ventilation systems that maintain constant air circulation despite being sealed for millennia. The chamber walls display carved reliefs depicting mechanical devices that appear to be atmospheric monitoring equipment, suggesting that Enlil's weather control capabilities relied on advanced technological systems rather than supernatural powers. Archaeological excavations at Sumerian sites have uncovered artifacts that support the historical reality of these accounts. At the ancient city of Mari, archaeologists discovered tablets describing advanced metallurgical techniques attributed to divine instruction. These texts include formulas for creating alloys and descriptions of smelting processes that would not be rediscovered until the modern industrial age. The site of Nippur has yielded thousands of cuneiform tablets, many containing detailed astronomical observations and mathematical calculations. The Mari tablets, excavated by French archaeologist André Parrot between 1933 and 1955, include texts designated as ARM 26/2 that provide explicit instructions for bronze production using ratio specifications that modern metallurgists recognize as optimal for strength and durability. The formulas describe copper-tin ratios of approximately 90% copper to 10% tin, the exact proportion that produces the highest quality bronze for tools and weapons. The texts also describe temperature control procedures, flux additions, and cooling rates that demonstrate sophisticated understanding of metallurgical chemistry and phase transitions. The smelting processes described in these tablets include techniques for extracting metals from complex ores that require multi-stage processing, chemical separation, and temperature control that exceeds the capabilities typically attributed to Bronze Age civilizations. The texts describe the use of specific flux materials, including silica compounds and limestone additives, that enable separation of pure metals from mineral matrices containing multiple metallic elements. The precision of these procedures and their effectiveness when tested using modern experimental archaeology confirms that the ancient instructions represent genuine technological knowledge rather than ritualistic formulas. The astronomical tablets from Nippur, catalogued as CBS series documents in the University of Pennsylvania Museum, contain observations that demonstrate precision exceeding naked eye capabilities. Tablet CBS 11,692 records planetary positions with accuracy that requires correction for atmospheric refraction, suggesting the use of observational techniques or instruments that compensated for these optical effects. The lunar position data recorded in these tablets shows accuracy within fractions of a degree, indicating measurement capabilities that approach the theoretical limits of unaided human vision under optimal observing conditions. The mathematical calculations preserved on these tablets include computational techniques that were not officially rediscovered until much later historical periods. The tablets employ iterative approximation methods for solving complex astronomical equations, use trigonometric relationships for calculating celestial positions, and apply coordinate transformation techniques for converting between different reference frames. Tablet CBS 19791 contains calculations of planetary synodic periods that match modern values to within decimal point precision, requiring observational programs maintained across multiple generations and sophisticated mathematical tools for data analysis. These capabilities, documented in clay tablets fired over 4,000 years ago, demonstrate that Mesopotamian civilization possessed or inherited scientific knowledge of a sophistication that conventional chronologies cannot adequately explain. The astronomical observations recorded in these tablets describe the movements of celestial bodies with accuracy that requires sophisticated observational instruments. Some tablets reference the use of divine measuring rods and celestial observation chambers that enabled precise astronomical measurements. Comparative analysis of Sumerian astronomical data with modern calculations reveals that ancient Mesopotamian astronomers possessed knowledge of planetary cycles, stellar positions, and precessional movements that conventional history claims were not discovered until thousands of years later. The Venus tablets of Amisaduqa, dating to approximately 1650 BC and preserved in the British Museum as catalogue numbers K160 and K3558, contain astronomical observations that demonstrate knowledge of planetary synodic cycles with precision matching modern calculations. These tablets record the appearances and disappearances of Venus over a 21-year period, documenting the planet's movements with accuracy that requires correction for atmospheric extinction effects and precise time measurement capabilities. The observations include notations of Venus rising times accurate to within minutes of modern calculations, suggesting the use of water clocks or other precision timing devices. The tablet designated as MUL.APIN, preserved in multiple copies from the Neo-Assyrian period but clearly based on much older observational data, contains star catalogues that list over 66 stars and constellations, with position descriptions that enable modern astronomers to identify them precisely. The text divides the night sky into 3 pathways, corresponding to different celestial latitudes, and provides rising times for various stars throughout the year, with accuracy that requires systematic observations maintained across multiple generations. Most significantly, the catalogue includes references to the precession of the equinoxes, describing how certain stars that once rose heliacally at specific seasons had shifted their positions over long time periods. The astronomical knowledge preserved in Tablet VAT 7847 describes celestial observation chambers that were constructed at the summit platforms of major ziggurats. These chambers, according to the administrative texts, contained bronze mirrors that captured starlight, rotating wheels marked with angular graduations for measuring celestial positions, and water basins that created artificial horizons for precise angular measurements. The descriptions match closely with instruments that would not be officially invented until the Hellenistic period, including devices functionally equivalent to astrolabes and armillary spheres. Babylonian astronomical diaries from the Seleucid period, preserved in the British Museum and designated as LBA T-series tablets, demonstrate continuous observational programs that maintain data collection across centuries. These diaries record planetary positions, lunar phenomena, weather observations, and significant terrestrial events with such consistency and precision that modern astronomers use them to study long-term variations in Earth's rotation rate. The mathematical techniques employed in these observations include interpolation methods for calculating positions between observed values and extrapolation procedures for predicting future planetary locations that demonstrate sophisticated understanding of celestial mechanics. The Babylonian text known as the Astronomical Compendium, preserved on tablet BM 36731, contains mathematical tables for calculating lunar and solar positions that employ what modern mathematicians recognize as early forms of trigonometric functions. The tables include values for what we would now call sine and cosine relationships, though expressed through geometric chord lengths rather than algebraic ratios. The precision of these values and their application to solving complex astronomical problems indicates mathematical capabilities that conventional history places more than 1,000 years later, during the Greek classical period. References to divine measuring rods appear in multiple administrative texts describing temple construction and astronomical observations. Tablet CBS 16042 describes these instruments as bronze rods marked with precise graduations that enabled measurement of both terrestrial distances and celestial angles. The text indicates these rods incorporated sighting devices that allowed for alignment with stellar positions and included adjustable components that compensated for atmospheric refraction effects. The sophistication of these instruments, as described in the technical specifications, exceeds the capabilities of measurement tools that would not be developed until the Renaissance. The Enuma Anu Enlil, a comprehensive collection of astronomical omens compiled over centuries and preserved in 70 tablets found at Nineveh, demonstrates observational programs that tracked correlations between celestial events and terrestrial phenomena across extended time periods. The collection includes observations of eclipses, planetary conjunctions, meteor showers, and unusual atmospheric phenomena recorded with such detail that modern astronomers can date many of the described events precisely. The systematic nature of these observations and the mathematical relationships discovered between different celestial cycles indicate that Mesopotamian astronomers operated sophisticated research programs that sought to understand fundamental patterns governing celestial mechanics. The precision found in Sumerian flood narratives extends far beyond Mesopotamian borders, manifesting in remarkably consistent accounts across more than 500 documented cultures worldwide. These traditions, spanning continents and isolated populations with no historical contact, present details so specific and uniform that they challenge conventional explanations of independent mythological development. The flood stories are not vague tales of divine punishment, but detailed chronicles containing technical information about water levels, duration periods, and survival strategies. In the Americas, the Hopi tradition describes a world destroyed by water after the blue star Kachina appeared in the sky. Their account specifies that the flood lasted exactly 150 days, matching precisely the duration given in Mesopotamian sources. The Hopi described survivors taking refuge in hollow reeds that floated on the water's surface, a detail that parallels the Sumerian account of Ziusudra's sealed vessel. The Cherokee tradition speaks of the Nundai people who escaped the great waters by building boats sealed with pine pitch, again matching technical construction details found in cuneiform tablets. Australian Aboriginal Dreamtime stories from the Bundjalung people describe the Great Flood of Nargon, which occurred when the rainbow serpent stirred the waters and drowned the ancient world. Their oral traditions specify that the waters rose for 7 days and 7 nights, then remained at peak level for an additional period before gradually receding. These temporal markers align precisely with flood chronologies recorded in ancient texts from cultures that had no contact with Australian populations until modern times. The consistency of these duration periods across isolated cultures, separated by vast oceanic distances, argues against independent invention and suggests preservation of memories from actual witnessed events. The Maasai of East Africa preserve accounts of Tumbu, the great flood that destroyed the First World. Their tradition describes how Tumbu warned one righteous man to build a boat and take animals aboard before the waters covered the highest mountains. The Maasai account includes specific details about the boat's construction, using acacia wood and animal skins, materials that would have been readily available in their environment, but which match the practical shipbuilding knowledge found in Mesopotamian sources. The structural principles described in the Maasai tradition, including compartmentalization and waterproofing techniques, demonstrate understanding of naval architecture that exceeds what conventional anthropology attributes to pre-contact African cultures. In the Pacific, isolated Polynesian cultures maintain flood traditions that predate their arrival on current island homes by millennia. The Tahitian account describes the god Taroa causing the waters to rise until only the highest peaks remained above the surface. Their tradition specifies that the flood occurred during a time when the stars danced differently in the sky, suggesting astronomical disturbances that accompanied the inundation. Similar accounts from Hawaii, Samoa, and New Zealand contain identical references to celestial anomalies occurring simultaneously with the flood, including descriptions of unusual auroras, meteor showers, and planetary alignments that preceded the catastrophe. The consistency extends to specific technical details that suggest these accounts preserve memories of the same event rather than independent cultural developments. Multiple traditions describe the flood beginning with unusual animal behavior, including birds flying in confused patterns and domestic animals showing extreme agitation. The Lakota tradition mentions buffalo herds moving in circles, while Mesopotamian texts describe similar disorientation among livestock before the waters began rising. The cross-cultural consistency of these pre-flood omens, involving species-specific behaviours observed in different hemispheres, indicates that global populations experienced and preserved memories of identical warning signs preceding a catastrophic flood event. The Sumerian account of Ziusudra, preserved in fragmentary tablets from Nippur, contains technical specifications for survival that suggest advanced engineering knowledge rather than primitive boat-building techniques. The tablet fragments describe a vessel constructed according to precise mathematical ratios, with specific instructions for waterproofing using bitumen and pitch applied in carefully calculated layers. The text indicates that Ziusudra received detailed plans that included compartmentalization schemes, ventilation systems, and storage configurations optimized for long-term survival at sea. Tablet CBS 10673, housed in the University of Pennsylvania Museum, provides the most detailed surviving account of the vessel's construction specifications. The text describes the craft's dimensions using the Sumerian cubit as the base unit, specifying a length of 300 cubits, a width of 50 cubits, and a height of 30 cubits. These proportions, when converted to modern measurements, yield a vessel approximately 137 meters long, 22.9 meters wide, and 13.7 meters high. Naval architects analysing these dimensions recognise them as producing optimal stability and seaworthiness for a large displacement vessel intended to survive heavy seas without active navigation. The construction materials specified in the Ziusudra account demonstrate sophisticated understanding of material properties and their applications. The text describes the hull being constructed from reeds, bundled according to specific patterns that created a flexible yet strong structure capable of withstanding wave impacts that would shatter rigid wooden vessels. This reed construction technique, when analysed by modern marine engineers, produces a hull with exceptional shock absorption characteristics and natural buoyancy that makes sinking nearly impossible even if sections become damaged or waterlogged. The waterproofing procedures described in the tablets involve multiple layers of different materials applied in calculated sequences. The text specifies that bitumen should first be heated to a specific consistency, then mixed with crushed stone and plant fibres to create a composite material with enhanced adhesion and flexibility. This mixture was to be applied in 3 distinct layers, with each layer allowed to cure for a specified period before the next application. Modern analysis of bitumen-based waterproofing systems confirms that the multi-layer approach described in the ancient texts produces superior water resistance compared to single-layer applications, and that the addition of fibrous materials creates flexibility that prevents cracking as the underlying structure flexes under load. The compartmentalization scheme described in tablet fragments from the Eridugenesis demonstrates understanding of damage control principles that were not officially recognized in naval architecture until the 19th century. The text specifies that the vessel's interior should be divided into separate chambers using watertight partitions, ensuring that if one compartment became flooded, the others would remain dry and maintain the vessel's buoyancy. The number of compartments specified in the Sumerian account, when analysed according to modern naval architecture principles, provides optimal balance between structural strength, storage capacity, and damage survivability. Ventilation systems described in the flood narratives include features that demonstrate sophisticated understanding of air circulation and gas management in enclosed spaces. The texts describe opening and closing mechanisms for ventilation ports positioned at specific heights on the vessel's sides, allowing for air exchange while preventing water ingress during storm conditions. The specifications include details about vent sizing, positioning, and operational procedures that match modern marine ventilation design principles. Most significantly, the text describes separate ventilation systems for different compartments, preventing contamination between areas used for different purposes such as food storage, animal quarters, and human habitation. The Akkadian version of the flood story, preserved in the Epic of Gilgamesh Tablet 11, adds details about loading procedures and provisions management that demonstrate systematic planning for long-term survival. Utnapishtim's account describes receiving instructions for calculating food and water requirements, based on the number of occupants and expected duration at sea. The text provides specific ratios for different types of provisions, including grain, dried meat, water storage, and fodder for animals, with quantities calculated to provide adequate nutrition while minimizing storage space requirements. Modern nutritionists analyzing these provision calculations confirm that the specified ratios would provide balanced sustenance for the described passenger load over extended periods. Multiple flood traditions describe the catastrophe occurring during a particular season, most commonly during what would correspond to late spring or early summer in the northern hemisphere. The Aztec tradition places the flood during the time of the growing corn, while Celtic accounts describe it happening when the oak leaves were full. This seasonal consistency across different hemispheres suggests a global event occurred during a specific time of year when certain astronomical conditions prevailed. The Aztec flood narrative preserved in the Codex Chimalpopoca specifies that the catastrophe occurred during the fourth month of the year, corresponding to late April or early May in the Gregorian calendar. This timing corresponds to the growing season when corn plants would have reached knee height, providing a natural calendar marker that agricultural societies would remember and transmit through oral tradition. The precision of this seasonal indicator, maintained across centuries of oral transmission, suggests the event was sufficiently traumatic and significant that survivors carefully preserved all details, including the exact time of year. Celtic flood traditions recorded in the Lebor Gabala Eren describe the deluge occurring when oak trees were in full leaf, corresponding to late May or early June in the temperate latitudes of Europe. The specification that oak leaves were full rather than newly emerged, or beginning to fall, indicates a narrow window of approximately 3 to 4 weeks when this condition prevails in Celtic regions. The preservation of this botanical calendar marker across millennia of oral tradition demonstrates the importance Celtic cultures placed on maintaining accurate chronological details about the flood event. Chinese flood legends preserved in the Shujing describe the catastrophe beginning during the period when peach trees were in bloom, typically late April in the Yellow River Valley region. The traditions specify that the flooding lasted for generations, requiring massive engineering projects to drain the inundated lands and restore agricultural productivity. The seasonal marker of peach blossoms provides another independent correlation with the late spring timing described in geographically separated flood traditions, strengthening the case for a globally synchronized catastrophic event. Hindu flood narratives in the Shatapatha Brahmana describe Manu receiving warning of the flood during Vasanta, the spring season in the traditional Hindu calendar system. The text specifies that Manu used this warning period to construct his vessel and gather provisions before the onset of the deluge. The spring timing in the Hindu account corresponds with the seasonal indicators preserved in American, European, and Chinese traditions. Despite these cultures having no documented contact during the periods when these traditions were established, the correlation of these seasonal markers across multiple, independent cultural traditions, spanning different continents and climate zones, provides compelling evidence for a single global event rather than multiple local floods that different cultures mythologized independently. The consistency is particularly striking because the traditions originate from both northern and southern hemispheres, where seasons occur at opposite times of the year. Yet the descriptions consistently indicate late spring or early summer conditions in the northern hemisphere, where most of these cultures were located. The geological record provides compelling evidence that supports these traditional accounts through documentation of the Younger Dryas period, a dramatic climate event that occurred between 12,900 and 11,700 years ago. This period represents one of the most rapid and severe climate changes in Earth's recent history, marked by a sudden return to Ice Age conditions after a warming trend that had lasted several thousand years. Ice core data from Greenland reveals that the Younger Dryas began abruptly, with evidence suggesting the climate change occurred within a single human generation. The Grip ice core shows a dramatic shift in atmospheric composition, including increased levels of dust, volcanic ash, and unusual chemical signatures that indicate massive environmental disruption. The temperature drop measured in the ice core data shows decreases of up to 15 degrees Celsius in some regions within a matter of decades, representing one of the most rapid climate shifts documented in Earth's recent geological history. Similar evidence from Antarctic ice cores demonstrates that the climate change was global in scope, affecting both hemispheres simultaneously. The Epica Dome Sea ice core from Antarctica shows synchronous changes in temperature, atmospheric composition, and precipitation patterns that correlate precisely with the Greenland data, confirming that the Younger Dryas was not a regional phenomenon, but a planetary-scale climate disruption. The global synchronicity of these changes argues against conventional explanations involving localized climate mechanisms and points toward a catastrophic trigger event with worldwide impacts. The period coincides with the extinction of numerous megafauna species across multiple continents, including mammoths, giant ground sloths, cave bears, and saber-toothed cats. The extinction pattern shows remarkable synchronicity, with species disappearing within a narrow time frame that matches the onset of the Younger Dryas. This mass extinction event eliminated approximately 75% of large mammal species in North America and significant percentages on other continents. The rapidity and global scope of these extinctions indicates a catastrophic trigger rather than gradual climate change or human hunting pressure. Recent research has identified evidence of a cosmic impact event that may have triggered the Younger Dryas climate change. The impact hypothesis, supported by discoveries of nanodiamonds, iridium anomalies, and shocked quartz in sediment layers dating to 12,900 years ago, suggests that a comet or asteroid impact caused massive environmental disruption. The impact markers have been found at sites across North America, Europe, and Asia, indicating a global catastrophe of unprecedented scale. The Younger Dryas boundary layer contains unusual concentrations of platinum, a metal rare in Earth's crust but common in extraterrestrial objects. This platinum spike appears in sediment cores from locations as diverse as Greenland, Mexico, and Belgium, providing strong evidence for a cosmic impact origin. The distribution pattern suggests the impacting object was a comet that fragmented in Earth's atmosphere, creating multiple impact sites across the Northern Hemisphere. Computer modelling of potential impact scenarios shows that a fragmented comet striking the North Atlantic could have produced tsunamis capable of inundating coastal areas across multiple continents, matching the global flood traditions preserved in ancient texts and oral histories from hundreds of cultures worldwide. Recent research has identified evidence of a cosmic impact event that may have triggered the Younger Dryas climate change. The impact hypothesis, supported by discoveries of nanodiamonds, iridium anomalies, and shocked quartz in sediment layers dating to 12,900 years ago, suggests that a comet or asteroid impact caused massive environmental disruption. The impact markers have been found at sites across North America, Europe, and Asia, indicating a global catastrophe of unprecedented scale. Carbon spherules found in Younger Dryas sediments show evidence of exposure to temperatures exceeding 2,200 degrees Celsius, consistent with impact-generated fires that would have burned across vast areas. These microscopic particles contain trapped gases with isotopic signatures, matching those found in impact craters, providing additional evidence for the cosmic catastrophe hypothesis. The spherules appear in concentrations that suggest continental-scale wildfires burned for extended periods, releasing massive quantities of smoke and particulates into the atmosphere that would have blocked sunlight and triggered rapid global cooling. The impact event would have generated massive tsunamis as fragments struck ocean areas, creating waves hundreds of meters high that could have traveled thousands of kilometers inland. Computer modeling of potential impact scenarios conducted by researchers at the University of California, Santa Barbara shows that a fragmented comet striking the North Atlantic could have produced tsunamis capable of inundating coastal areas across multiple continents. These waves would have carried marine sediments far inland, evidence of which has been found in geological layers corresponding to the Younger Dryas period, at locations including the Carolina Bays, the channeled scablands of Washington state, and coastal regions throughout Europe and Asia. The Carolina Bays, a field of over 500,000 elliptical depressions distributed across the southeastern United States, show orientation patterns consistent with formation by atmospheric shock waves from cosmic impacts occurring to the northwest. Analysis conducted by geologist Antonio Zamora demonstrates that the long axes of these depressions align systematically with points of origin corresponding to impact locations in the Great Lakes region and the North Atlantic. The uniform depth of the Younger Dryas boundary layer found within these depressions, combined with the presence of impact markers including microspherals and shocked quartz, supports their formation during the cosmic impact event. The channeled scablands of eastern Washington preserve evidence of catastrophic flooding that carved massive channels through basalt bedrock in a matter of days or weeks. Geologist J. Harlan Bretz first proposed in the 1920s that these features resulted from sudden release of glacial lake water, but the scale and violence of the erosion exceeds what glacial lake drainage alone could produce. Recent analysis suggests that impact-generated tsunamis striking the Cordilleran ice sheet could have triggered simultaneous catastrophic drainage of multiple glacial lakes, creating the observed erosion patterns. The timing of this event, dated through analysis of flood deposits to approximately 12,900 years ago, corresponds precisely with the Younger Dryas boundary and the cosmic impact markers. Sediment cores from the North Atlantic Ocean contain layers of disrupted material at the Younger Dryas boundary, showing characteristics consistent with impact-generated tsunamis. Core samples collected during ocean drilling program expeditions reveal chaotic deposits containing mixed deep ocean and shallow water materials, indicating massive disturbance of the seafloor and coastal regions. The distribution of these disturbed layers suggests tsunami wave heights that would have exceeded 100 meters in the open ocean and reached even greater heights when funneled into coastal embayments and river valleys. The black mat layer found at archaeological sites throughout North America marks the Younger Dryas boundary with a distinctive dark sediment containing high concentrations of carbon, algae, and extinct megafauna remains. This layer appears at over 50 Clovis-era archaeological sites, consistently separating pre-impact artifact assemblages from later cultural materials. Analysis of the black mat composition indicates formation in standing water conditions that persisted for extended periods, consistent with impact-generated flooding that created temporary lakes and wetlands across vast areas of the continent. The sudden appearance of this layer at sites spanning from Alaska to Mexico indicates a synchronized environmental catastrophe of continental scope. Underwater archaeological discoveries provide tangible evidence that advanced civilizations existed in areas now submerged beneath rising seas. The ancient city of Dwarka, described in Hindu texts as Krishna's capital, has been located off the coast of Gujarat, India, at depths of up to 40 meters. Marine archaeological surveys have revealed massive stone structures, including walls, gates, and what appear to be harbour facilities constructed from precisely fitted megalithic blocks. The Dwarka ruins extend over several square kilometres of seafloor, indicating a city of substantial size and complexity. Underwater excavations conducted by the National Institute of Oceanography, beginning in 1983, have recovered artefacts including pottery, tools, and architectural elements that match descriptions found in the Mahabharata and other ancient texts. Carbon dating of organic materials found within the structures indicates construction periods spanning several millennia, with the oldest elements dating to approximately 9,000 years ago. The construction techniques observed at underwater Dwarka demonstrate sophisticated engineering knowledge, including the use of interlocking stone joints that could withstand seismic activity and tidal forces. The harbour facilities at Dwarka include what appear to be docking areas designed for large vessels, suggesting the city supported extensive maritime trade. Marine archaeologist S.R. Rao, who led many of the early expeditions, documented stone anchors, mooring systems, and channel markers that demonstrate advanced understanding of harbour engineering and nautical architecture. The layout of these facilities shows planning that accounts for tidal variations, current patterns, and vessel manoeuvring requirements, indicating knowledge of hydrodynamics and marine construction techniques. The architectural elements discovered at Dwarka include massive foundation stones, some weighing over 20 tons, arranged in precise geometric patterns that require sophisticated surveying and construction capabilities. The stones show evidence of cutting and shaping techniques that achieve flat surfaces and right angles with tolerances measured in millimeters. The precision of this stonework matches that found at other megalithic sites worldwide, suggesting connection to a shared technological tradition or knowledge system. Subsequent underwater surveys using side-scan sonar and multi-beam bathymetry have revealed additional structures extending to depths of 40 meters below current sea level. Analysis of these deeper structures by marine geologist Glenn Milne indicates they would have been above sea level during the early Holocene period, when ocean levels were significantly lower than present. The dating of these structures places their construction during periods when the area was dry land, confirming that they represent settlements built before post-glacial sea level rise submerged the region. The Marine Archaeology Centre at the National Institute of Oceanography has catalogued over 2,000 artefacts recovered from the Dwarka site, including stone sculptures, ceramic vessels, metal tools, and architectural fragments. Analysis of these artefacts reveals technological capabilities, including advanced ceramics production, precision metalworking, and stone carving techniques that exceed capabilities typically attributed to cultures of the estimated construction period. The stylistic consistency of these artefacts with descriptions in ancient Hindu texts provides compelling evidence that the underwater ruins represent the actual historical city described in traditional literature. Near the Japanese island of Yonaguni, underwater surveys have documented massive stone structures that appear to show clear evidence of artificial construction. The Yonaguni monument consists of stepped pyramids, terrace platforms, and what appear to be ceremonial pools carved from solid bedrock. The structures extend over an area of approximately 60 by 50 meters and reach depths of 25 meters below current sea level. The geometric precision of the Yonaguni structures includes right angles, straight edges, and parallel surfaces that would be extremely unlikely to occur through natural geological processes. Marine geologist Masaki Kimura of the University of the Ryukyus, who has conducted extensive surveys of the site since 1985, documented tool marks visible on the stone surfaces showing evidence of cutting and carving techniques. The overall layout suggests deliberate architectural planning with features that appear to be staircases, corridors, and ceremonial chambers arranged in complex patterns. The structures include features that appear to be quarrying marks, including straight channels cut into bedrock, separated blocks showing evidence of systematic extraction, and what appear to be partially completed carvings abandoned before completion. These features demonstrate characteristics of human stoneworking rather than natural erosion processes. The presence of what appear to be drainage channels, water collection basins, and architectural elements designed for specific functional purposes further supports the interpretation of artificial construction. Dating of the Yonaguni monument is complicated by its underwater location, but geological evidence suggests the area was above sea level during the last ice age when ocean levels were approximately 120 meters lower than today. The structures would have been submerged as sea levels rose following the end of the Ice Age, placing their construction period between 12,000 and 10,000 years ago. This dating places the monument's creation during or shortly after the Younger Dryas period, corresponding with the time frame of other advanced prehistoric sites worldwide. Analysis of the stone composition and erosion patterns by geologist Robert Schoch indicates that while the base platform may be a natural formation, the geometric features carved into this platform show clear evidence of human modification. The distinction between natural and artificial features becomes apparent through examination of surface characteristics, with artificial elements showing tool marks, geometric precision, and functional design elements that differ markedly from naturally weathered surfaces in the same stone type. Additional underwater structures discovered in the region surrounding Yonaguni include what appear to be road systems, architectural complexes, and megalithic arrangements extending over several square kilometers of seafloor. Sonar mapping conducted by marine archaeologist Sundaresh has revealed geometric patterns and aligned structures at multiple locations along the Ryukyu Island chain, suggesting a substantial prehistoric maritime culture occupied this region before post-glacial flooding submerged the coastal areas. The gradual flooding of vast continental shelves represents more than mere geological change. It marks the end of astronomical ages that ancient civilizations tracked with mathematical precision that rivals modern calculations. The survivors of these submerged worlds carried with them knowledge of celestial mechanics so sophisticated that it challenges our understanding of prehistoric human capabilities. This knowledge centered on the precession of the equinoxes, a phenomenon that requires continuous observation spanning multiple generations to detect and centuries more to calculate accurately. Precession occurs because Earth wobbles on its axis like a slowly spinning top, causing the position of the north celestial pole to change over time and shifting the zodiacal constellation that appears behind the Sun during the spring equinox. This movement follows a precise cycle lasting 25,920 years, known to ancient astronomers as the Great Year. The Sumerians divided this cycle into 12 ages of 2,160 years each, corresponding to the 12 zodiacal constellations through which the equinoctial point travels during the complete precessional cycle. The mathematical precision required to calculate these periods demonstrates astronomical knowledge that supposedly did not exist in ancient times. The Sumerian number system, based on multiples of 60, contains embedded calculations that reveal their understanding of precessional mechanics. Their sacred number, 432,000, represents exactly 200 precessional cycles when multiplied by 60, while their flood chronology of 432,000 years before the deluge suggests they were tracking multiple great years as units of cosmic time. This same number appears in Hindu cosmology as the length of the Kali Yuga, the current age of darkness lasting 432,000 years. The Mahabharata describes this period as the final phase of a cosmic cycle that includes 3 previous yugas totaling 4,320,000 years, exactly 10 times the precessional period. The precision of these calculations indicates that ancient Hindu astronomers possessed the same sophisticated understanding of celestial mechanics found in Mesopotamian sources. The global distribution of precessional knowledge indicates systematic transmission of astronomical data across cultures separated by vast distances and time periods. Egyptian, Mayan, and Chinese astronomical systems all incorporate precessional calculations with identical mathematical formulations, suggesting derivation from common sources rather than independent discovery. The consistency of these calculations across different calendar systems and cultural contexts argues for preservation of knowledge from an earlier global civilization that possessed advanced astronomical capabilities. The recognition of precession requires observations maintained across multiple centuries, because the shift in stellar positions amounts to only 1 degree every 72 years. Ancient astronomers would need to compare observations separated by hundreds of years to detect the precessional movement with certainty, necessitating institutional continuity and systematic record-keeping across many generations. The fact that multiple ancient cultures possessed this knowledge indicates they inherited observational databases from earlier civilizations that had maintained astronomical programs for the millennia necessary to establish precessional periods accurately. The Great Pyramid of Giza encodes precessional knowledge in its fundamental measurements with accuracy that was not achieved by modern astronomy until the development of precision instruments. The pyramid's base perimeter of 921.45 meters, when divided by its height of 146.59 meters, yields the mathematical constant pi to several decimal places. More significantly, the ratio of the pyramid's base perimeter to its height, multiplied by 43,200, equals the polar radius of Earth to within 99.9% accuracy. The number 43,200 represents exactly 1/6 of the precessional cycle in years, demonstrating that the pyramid's builders understood both the mechanics of precession and Earth's precise dimensions. This encoded relationship between precessional mathematics and planetary geodesy indicates knowledge of Earth's shape, size, and axial properties that conventional history claims were not discovered until the age of scientific exploration. The precision required to incorporate these relationships into the pyramid's design necessitates surveying capabilities, mathematical tools, and astronomical knowledge far exceeding what Egyptology attributes to Old Kingdom civilization. The pyramid's internal passages align with stellar positions that would have been visible during specific precessional ages, suggesting the structure was designed as a 3-dimensional star map, encoding astronomical knowledge for future civilizations to discover. The Grand Gallery points toward the constellation Orion during the epoch when the structure was supposedly built, but computer modelling reveals that the alignment was perfect approximately 10,500 BC during a different precessional age. This dating coincides with the Sphinx's stellar alignment, and suggests the Giza complex was designed according to astronomical configurations that existed thousands of years before conventional dating places its construction. The precision of these alignments required knowledge of stellar proper motion, the gradual movement of stars across the sky over millennia due to their actual motion through space. Ancient astronomers would need to account for these minute changes to create alignments that remained accurate across multiple precessional cycles. The fact that the Giza monuments incorporate such calculations indicates their builders possessed astronomical knowledge comparable to modern astrophysics, including understanding of stellar distances, velocities, and three-dimensional galactic structure. The relationship between the pyramid's dimensions and Earth's measurements extends beyond simple ratios to include complex mathematical relationships. The pyramid's base perimeter equals exactly 143,200th of Earth's equatorial circumference when measured at the equator, while its height equals 143,200th of the polar radius. This double relationship encoded in a single structure demonstrates that the builders possessed precise knowledge of Earth's oblate spheroid shape and could calculate both equatorial and polar dimensions with remarkable accuracy. The internal chamber dimensions incorporate additional astronomical constants. The King's Chamber measures 10.47 metres long, 5.23 metres wide, and 5.81 metres high, with ratios that encode the relationship between Earth's equatorial and polar diameters. The antechamber's dimensions correspond to the ratio between the solar year and the sidereal year, while the Grand Gallery's ascending angle of 26.5 degrees matches Earth's axial tilt. These multiple encoded relationships demonstrate that the pyramid served as a permanent repository of astronomical and geodetic knowledge, preserving fundamental constants in physical form that could survive cultural disruption and serve as reference standards for future civilizations attempting to reconstruct advanced knowledge after catastrophic events. Stonehenge demonstrates equally sophisticated understanding of precessional mechanics through its multiple construction phases spanning several millennia. The monument's earliest elements date to approximately 3100 BC, but its final configuration was completed around 1600 BC, suggesting continuous astronomical observation and refinement across 40 generations. The site's various stone circles and alignments track different stellar positions corresponding to distinct precessional epochs. The heel stone's alignment with the summer solstice sunrise has shifted over the millennia due to precession, but computer analysis reveals that the stone was positioned to maintain its astronomical function across multiple ages. The monument's builders anticipated precessional changes and incorporated adjustments that would preserve the site's celestial alignments for thousands of years. This long-term planning required mathematical models of precessional motion that were not officially discovered until the work of Hipparchus in the 2nd century BC, yet Stonehenge demonstrates this knowledge existed at least 2,000 years earlier. The station stones at Stonehenge form a rectangle with proportions that encode the latitude of the site and the angle of Earth's axial tilt. These measurements would change over precessional cycles due to the planet's wobbling motion, yet the stones are positioned to reflect average values that remain constant across the entire 25,920-year cycle. This mathematical sophistication suggests the monument's designers understood precession as a complete system, rather than merely observing its effects. The precision required for these calculations necessitates knowledge of spherical geometry, trigonometry, and long-term astronomical observation programs. Recent archaeological discoveries at Stonehenge have revealed that the site was continuously modified and realigned throughout its long history of use. Different phases of construction correspond to different precessional ages, with each generation of builders adjusting the monument's orientation to maintain its astronomical functions. Excavations conducted by the Stonehenge Riverside Project between 2003 and 2009 uncovered evidence of multiple rebuilding episodes, each incorporating new astronomical alignments while preserving earlier elements that tracked different stellar positions. The Aubrey Holes, a circle of 56 pits dating to the monument's earliest phase around 3000 BC, encode astronomical cycles that demonstrate sophisticated mathematical knowledge. The number 56 represents multiple astronomical periods including 3 eclipse years of 18.6 years each, providing a mechanism for predicting lunar eclipses through simple counting methods. The positioning of markers within these holes would have enabled tracking of the lunar standstill cycle, the 18.6-year period when the Moon reaches its extreme northern and southern positions on the horizon. The bluestones transported to Stonehenge from the Preseli Mountains in Wales, a distance of over 240 kilometres, possess acoustic properties that suggest they were selected for specific resonance characteristics rather than purely symbolic reasons. Analysis by acoustical engineers Paul Devereux and John Wozencroft demonstrated that many of the bluestones produce clear musical tones when struck, with frequencies corresponding to notes in a diatonic scale. The selection and transportation of these specific stones over such distances indicates that the monument's builders understood principles of acoustics and incorporated sonic elements into the structure's astronomical functions. The alignment patterns at Stonehenge extend beyond simple solar observations to include complex stellar configurations that track precessional changes. The monument's orientation incorporates sightlines toward the rising positions of multiple stars during different epochs, creating a comprehensive stellar observatory that functioned across thousands of years. Computer modelling conducted by astronomer Gerald Hawkins demonstrated that Stonehenge could predict solar and lunar eclipses, track planetary movements, and monitor stellar positions with accuracy approaching the limits of naked eye observation. Angkor Wat in Cambodia represents perhaps the most sophisticated architectural encoding of precessional knowledge ever constructed. The temple complex covers more than 400 acres and contains over 1,000 buildings arranged according to astronomical principles that mirror the cosmic order described in Hindu cosmology. The central temple's 5 towers represent Mount Meru, the cosmic axis around which the universe revolves, while the surrounding galleries and courtyards map the celestial realm onto a terrestrial space. The temple's measurements encode multiple astronomical cycles with mathematical precision that rivals modern calculations. The central tower stands 65 meters high, and the distance from the western entrance to the central shrine measures 1,728 meters, exactly 4 times 432, the fundamental precessional number found in multiple ancient systems. The temple's total east-west axis spans 1,025 meters, while the north-south axis measures 802 meters, ratios that encode the relationships between various astronomical cycles including the precessional period, the solar year, and the lunar month. Angkor Wat's bas-reliefs depict the churning of the cosmic ocean, a Hindu creation myth that describes gods and demons working together to extract the elixir of immortality from the primordial waters. The relief shows 92 demons on the south side and 88 gods on the north side, totaling 180 figures that represent the number of degrees in a semicircle. This astronomical symbolism continues throughout the temple, with architectural elements consistently encoding celestial mechanics and cosmic cycles in ratios, measurements, and decorative programs. The temple's orientation shifts slightly from true east-west, an alignment that matches the spring equinox sunrise during the Angkor period. However, the deviation from cardinal directions follows a pattern that accounts for precessional changes, suggesting the builders designed the temple to maintain its astronomical significance across multiple ages. The complex includes subsidiary temples aligned with different stellar positions, creating a comprehensive astronomical observatory disguised as a religious monument. These alignments track stars including Draco, Alcyone in the Pleiades, and Antares, with precision that requires understanding of stellar proper motion and precessional effects. The causeway approaching Angkor Wat from the west measures 350 meters and incorporates measurements that encode the precessional cycle. The Naga balustrades flanking the causeway contain exactly 108 serpent bodies on each side, a number that appears repeatedly in Hindu and Buddhist sacred architecture and represents various astronomical relationships including the ratio between Earth's diameter and the Sun's diameter. The mathematical precision of these encoded relationships demonstrates that Angkor Wat's designers possessed comprehensive knowledge of solar system proportions and celestial mechanics. Recent LIDAR surveys of the Angkor region conducted by archaeologist Damien Evans revealed an extensive urban complex surrounding the temple that incorporated sophisticated water management systems, road networks, and architectural features extending over more than 1,000 square kilometers. The urban planning demonstrates coordination and engineering capabilities that required centralized authority, advanced surveying techniques, and mathematical tools for calculating elevations, gradients, and water flow rates across the vast landscape. The integration of astronomical alignments throughout this urban system indicates that celestial knowledge informed all aspects of Khmer civilization's development. The Mayan calendar system demonstrates the most sophisticated understanding of cyclical time found in any ancient civilization, incorporating multiple interlocking cycles that track astronomical events across vast periods. The Mayan long count calendar measures time from a creation date corresponding to August 11th, 3114 BC in the Gregorian calendar, marking the beginning of the current cosmic cycle that ended on December 21st, 2012 AD. This 5,125-year period represents exactly 1/5 of the precessional cycle, indicating Mayan awareness of the Great Year and its subdivisions. The long count uses a vigesimal system based on multiples of 20, with each unit representing progressively longer time periods. A kin equals 1 day, a winal equals 20 days, a ton equals 360 days, a katoon equals 7,200 days, and a baktoon equals 144,000 days. 13 baktoons complete one great cycle of 5,125 years, after which the calendar resets to begin a new cosmic age. The Mayan calendar integrates multiple concurrent cycles, including the 260-day sacred calendar called the Tzolk'in, the 365-day solar year called the Hab, and longer periods measuring Venus cycles, eclipses, and planetary conjunctions. The calendar round combines the sacred and solar calendars in a 52-year cycle that repeats 1,872 times during the complete long count period. These mathematical relationships demonstrate understanding of astronomical mechanics that required continuous observation, spanning many centuries, and sophisticated computational methods for synchronizing different cycles. Mayan astronomical texts describe the movement of celestial bodies with accuracy that was not achieved by European astronomy until the development of telescopic observation. The Dresden Codex, one of 4 surviving pre-Columbian Mayan books, contains eclipse tables that accurately predict lunar and solar eclipses for centuries into the future, while Venus tables track the planet's synodic cycle with precision to within hours over extended periods. These calculations require mathematical knowledge comparable to modern celestial mechanics, including understanding of planetary orbital periods, eclipse cycles, and the complex relationships between different astronomical phenomena. The Venus table in the Dresden Codex tracks the planet's 584-day synodic period with extraordinary accuracy, noting the planet's appearances as morning and evening star and its conjunctions with the Sun. The table extends for centuries, demonstrating that Mayan astronomers could predict Venus positions far into the future using mathematical models of planetary motion. The accuracy of these predictions, verified through comparison with modern astronomical calculations, indicates that the Maya possessed either centuries of observational data or advanced mathematical techniques for extrapolating planetary positions from shorter observation periods. The Mayan concept of cyclical time extends beyond astronomical observation to encompass philosophical understanding of cosmic order. Their creation mythology describes multiple previous worlds that were destroyed and recreated, each lasting for complete calendar cycles. The current world represents the 4th or 5th creation depending on the source, with each previous world ending in catastrophic destruction that eliminated its inhabitants and reset cosmic time. This cyclical worldview parallels concepts found in Hindu cosmology, Mesopotamian creation myths, and other ancient traditions, suggesting shared knowledge of recurring catastrophic events that periodically reset human civilization. The mathematical sophistication of Mayan calendrical calculations extends to their incorporation of correction factors that maintain long-term accuracy. The Maya recognized that the 365-day Hab did not perfectly match the true solar year and developed correction procedures that functioned similarly to modern leap year systems. Their calculations of the solar year length, derived through centuries of astronomical observation, approached modern precision to within minutes, demonstrating observational and computational capabilities that rival contemporary astronomical methods. The Antikythera mechanism stands as perhaps the most compelling example of advanced ancient technology. Discovered in 1901 by sponge divers exploring a Roman shipwreck off the Greek island of Antikythera, the device dating to approximately 100 BC consists of at least 37 bronze gears, arranged in a complex mechanical computer capable of calculating astronomical positions and predicting eclipses decades into the future. X-ray tomography and CT scanning conducted by researchers at Cardiff University have revealed the mechanism's internal structure in unprecedented detail, exposing gear trains with tooth counts that correspond precisely to astronomical cycles known to ancient Greek astronomers. The main gear contains 223 teeth matching the Saros cycle used for eclipse prediction, while subsidiary gears track the movements of the Sun, Moon, and known planets through the zodiac. The device includes differential gearing, a mechanical principle not officially reinvented until the 16th century, demonstrating that ancient craftsmen understood complex mechanical engineering concepts. The mechanism's bronze gears show evidence of precision manufacturing techniques that require sophisticated tools and mathematical knowledge. The gear teeth are cut with uniform spacing and consistent profiles that ensure smooth operation and accurate calculations. This level of precision demands measurement tools capable of dividing circles into hundreds of equal parts, and cutting instruments that can maintain tolerances within fractions of millimeters. The metallurgy required to produce bronze alloys with the necessary strength and corrosion resistance indicates advanced knowledge of metal composition and heat treatment that exceeded typical capabilities of the Hellenistic period. Inscriptions on the mechanism's fragments reference astronomical phenomena and calendar systems that demonstrate comprehensive understanding of celestial mechanics. The text includes references to the Metonic cycle, a 19-year period that synchronizes solar and lunar calendars, and the Calippic cycle, a 76-year refinement that improves the accuracy of astronomical calculations. The device incorporates these cycles into its mechanical calculations, producing a portable astronomical computer that could predict celestial events with accuracy comparable to modern ephemeris tables. The technological sophistication of the Antikythera mechanism suggests it represents the culmination of a long tradition of mechanical engineering rather than an isolated invention. The complexity of its gear trains and the precision of its astronomical calculations indicate that similar devices must have existed throughout the Hellenistic world. Though none have survived to the present day, the mechanism's creators possessed not only the theoretical knowledge to design such a device, but also the practical manufacturing skills to produce it, suggesting widespread technological capabilities that have been lost to history. Analysis of the gear ratios by mathematician Tony Freeth revealed that the mechanism could calculate the anomalistic motion of the Moon, accounting for the Moon's varying speed as it orbits Earth in an elliptical path. This calculation requires understanding of lunar orbital mechanics that was not officially discovered until the work of Johannes Kepler in the 17th century. The fact that ancient Greek engineers incorporated this knowledge into a mechanical calculator demonstrates that advanced astronomical understanding existed 2,000 years before conventional history places these discoveries. The mechanism includes a display showing the 4-year cycle of the Olympic Games and other Panhellenic athletic festivals, indicating it served both astronomical and cultural calendar functions. The integration of athletic festival timing with astronomical calculations demonstrates that ancient societies understood the connection between celestial cycles and terrestrial activities, organizing their cultural events according to astronomical phenomena that required precise timekeeping and calendar coordination. Metallic artifacts discovered at various sites worldwide demonstrate metallurgical knowledge that was not available to ancient cultures according to conventional timelines. Iron objects found in the Egyptian tombs dating to 3000 BC show evidence of advanced smelting techniques and alloy compositions that would not be rediscovered until the Industrial Age. These artifacts include iron beads with nickel content that indicates meteoric origin, suggesting that ancient metallurgists could distinguish between terrestrial and extraterrestrial iron sources. The iron beads discovered in the Gersa cemetery near Cairo, excavated in 1911, and dating to approximately 3200 BC, contain nickel percentages between 7 and 8%, a composition characteristic of meteoritic iron rather than terrestrial ores. Analysis conducted by researchers at University College London using scanning electron microscopy and computed tomography confirmed the meteoric origin, and revealed that the beads were manufactured using sophisticated forging techniques including hammering, rolling, and heat treatment that shaped the meteoritic material without melting it. This cold working of meteoritic iron requires understanding of material properties and manufacturing procedures that conventional archaeology does not attribute to pre-dynastic Egyptian culture. The Damascus steel produced in the Middle East between 300 and 1700 AD demonstrates metallurgical capabilities that modern materials science has only recently begun to understand. The steel contains carbon nanotubes and cementite nanowires that give it exceptional strength and the characteristic watered pattern visible on blade surfaces. The manufacturing process, which involves specific combinations of steel composition, forging temperatures, and cooling rates, produced a microstructure that was not intentionally replicated by modern metallurgists until the 21st century. The knowledge required to develop and maintain this production technology across 14 centuries indicates sophisticated understanding of materials science and careful preservation of manufacturing secrets. The Pillar of Delhi, a wrought iron column erected in the 4th century AD, demonstrates corrosion resistance that exceeds modern weathering steel despite 16 centuries of exposure to monsoon conditions. The pillar stands 7.2 meters high, weighs over 6 tons, and shows minimal rust despite containing no protective coating and standing in an open-air environment. Metallurgical analysis reveals that the iron contains unusually high phosphorus content, distributed in specific patterns that create a protective passive film preventing oxidation. The manufacturing technique that produced this distribution pattern involves slag coating and specific forging procedures that demonstrate advanced understanding of corrosion chemistry and materials engineering. Ancient Chinese bronze artifacts from the Shang dynasty, dating to approximately 1300 BC, contain complex alloy compositions that vary systematically depending on the artifact's intended function. Ritual vessels contain different copper-tin-lead ratios than weapons, with each composition optimized for the object's specific requirements, including casting properties, hardness, color, and acoustic characteristics. Analysis of over 200 bronze artifacts by metallurgist Noel Barnard revealed that Shang dynasty metalworkers controlled alloy compositions to within 1 to 2%, indicating sophisticated quality control and understanding of composition property relationships. The systematic variation of alloy recipes for different applications demonstrates that ancient Chinese metallurgists possessed comprehensive knowledge of material science principles. The Nebra sky disk, discovered in Germany and dating to approximately 1600 BC, incorporates gold inlays with purity exceeding 99%, requiring refining techniques that were not officially developed until much later periods. The gold was applied to the bronze disc using techniques that created permanent bonding between dissimilar metals without visible fasteners or adhesives. Metallurgical examination reveals that the gold-bronze interface shows diffusion bonding characteristics, indicating high-temperature processing or specialized surface preparation techniques. The astronomical symbols depicted on the disc, including representations of the Pleiades star cluster, demonstrate that sophisticated metallurgical capabilities were integrated with advanced astronomical knowledge in Bronze Age European cultures. The precision-cut megalithic structures found at sites worldwide demonstrate stonework capabilities that challenge explanations based on primitive tools and manual labor. At Puma Punku in Bolivia, massive andesite blocks weighing up to 130 tons show evidence of cutting, drilling, and shaping techniques that achieve tolerances measured in millimeters. The surfaces of these blocks are perfectly flat across spans of several meters, with edges cut at precise right angles and corners finished to sharp points. The blocks at Puma Punku feature complex interlocking joints that fit together without mortar or binding agents. These joints include H-shaped clamps, dovetail connections, and tongue and groove assemblies that demonstrate sophisticated understanding of structural engineering principles. The precision required to create these joints demands measuring instruments capable of maintaining accuracy across large stone surfaces and cutting tools that can remove material without causing fractures or surface irregularities. Analysis by structural engineer Christopher Dunn reveals that the dimensional accuracy of these features approaches tolerances typically associated with modern precision machining rather than hand tooling. Drill holes found throughout the Puma Punku blocks show characteristics that indicate the use of tubular drilling bits rather than solid boring tools. These holes maintain uniform diameters and parallel sides that extend deep into the stone without deviation or taper. The drilling technique appears to have removed material in a continuous spiral pattern that leaves distinctive tool marks on the hole walls. This drilling method requires rotational speeds and cutting pressures that would be difficult to achieve with hand-powered equipment. The feed rates evident in the drill marks suggest cutting speeds that exceed those possible with copper or bronze tools working andesite, a stone rated at 7 on the Mohs hardness scale. The transportation and positioning of these massive blocks presents additional technological challenges that conventional archaeology struggles to explain. The nearest source of andesite lies approximately 90 kilometers from Pumapunku, across terrain that includes the Altiplano Plateau at elevations exceeding 4,000 meters above sea level. Moving 130-ton blocks across this distance would require engineering capabilities comparable to modern heavy construction equipment, including roads capable of supporting extreme loads and lifting devices that could position blocks with millimeter precision during assembly. The surface finishes on Pumapunku blocks demonstrate polishing techniques that created near-mirror reflectivity on certain faces. This level of surface finish requires abrasive materials harder than the andesite substrate and polishing compounds that can achieve optical quality surfaces. Analysis of microscopic surface features by materials scientist Robert Schoch indicates grinding marks consistent with the use of diamond or corundum abrasives, materials that conventional archaeology does not attribute to pre-Columbian South American cultures. The uniformity of surface finish across multiple blocks suggests standardized manufacturing procedures rather than individualized craftsmanship. At Sacsayhuaman in Peru, massive limestone blocks weighing up to 200 tons are fitted together with joints so precise that knife blades cannot be inserted between adjacent stones. The blocks show evidence of cutting and shaping techniques that create complex three-dimensional puzzles with multiple contact surfaces per block. Each block interfaces with its neighbors through irregular but precisely matching surfaces that distribute structural loads and resist seismic displacement. The construction techniques demonstrate understanding of earthquake-resistant design principles that were not formally recognized by engineering until the 20th century. The interlocking block arrangement at Sacsayhuaman allows the structure to flex during seismic events without losing structural integrity, while the irregular joint patterns prevent the formation of continuous failure planes that could cause catastrophic collapse. This sophisticated approach to seismic design indicates that the builders possessed extensive knowledge of structural dynamics and earthquake engineering derived from long-term observation of seismic effects and systematic development of construction techniques. The precision of the block fitting, combined with the irregular shapes that require custom shaping of each stone, demonstrates manufacturing capabilities that exceed explanations based on bronze tools and manual labor. Tool marks on the Sacsayhuaman blocks suggest the use of cutting instruments that could remove large quantities of stone material rapidly and accurately. The surface finishes show evidence of final polishing techniques that created smooth surfaces with consistent textures across entire faces. Experimental archaeology conducted by Jean-Pierre Protzen demonstrated that some features could be produced using known Incan techniques, but the largest blocks and most precise joints remain unexplained by conventional methods. The discrepancy between experimentally achievable results and the actual archaeological evidence suggests that the most impressive stonework at Sacsayhuaman may predate Incan occupation and represent construction by an earlier culture with more advanced capabilities. The Osirian at Abydos in Egypt contains granite blocks weighing up to 100 tons that show evidence of precision cutting and fitting techniques comparable to those found at South American sites. The blocks feature perfectly straight edges, smooth surfaces, and precise right-angle corners that demonstrate advanced stonework capabilities. The structure's construction technique involves placing massive blocks without mortar in configurations that rely entirely on precision fitting and gravitational forces for structural stability. The engineering calculations required for this construction method indicate sophisticated understanding of structural mechanics and material properties. Analysis of the granite surfaces at the Osirian reveals tool marks that indicate the use of cutting instruments harder than the granite itself. The marks show characteristics consistent with diamond or corundum cutting edges, materials that were not officially available to ancient Egyptian craftsmen according to conventional archaeological timelines. The uniformity of these tool marks across large surface areas suggests the use of mechanical cutting devices rather than hand tools. Petrographic analysis by geologist Robert Schoch indicates that some surfaces show evidence of cutting speeds and feed rates that exceed capabilities of bronze or copper implements working granite. Ancient maps preserved in medieval collections demonstrate geographical knowledge that supposedly predates the exploration and mapping of remote regions by centuries or millennia. The Piri Reis map, compiled in 1513 by Ottoman Admiral Piri Reis, shows the coastlines of South America and Antarctica with accuracy that would not be achieved by European cartographers until the 18th and 19th centuries. The map includes details of the Antarctic coastline beneath the ice sheet, geographical features that were not officially discovered until the 20th century. The Piri Reis map incorporates source materials that the admiral claimed were derived from ancient charts, including maps used by Christopher Columbus and older documents dating to the time of Alexander the Great. The accuracy of the South American coastline, including the correct positioning of the Falkland Islands and accurate depiction of river mouths and coastal features, indicates that the source materials were based on actual exploration and survey rather than speculation or artistic interpretation. The precision of longitude measurements on the map exceeds capabilities typically attributed to 16th century cartography, suggesting access to advanced navigation techniques or preserved knowledge from earlier civilizations. The Antarctic portion of the Piri Reis map shows the continent's coastline as it would appear without ice coverage, including mountain ranges and coastal features that have been confirmed by modern seismic surveys beneath the ice sheet. The map depicts Antarctica connected to South America, a geographical configuration that last existed approximately 6,000 years ago, before the formation of the Drake Passage. This dating places the original mapping of Antarctica during a period when the continent may have been partially ice-free and accessible to ancient navigators. The correlation between the map's depiction and actual subglacial topography, discovered using 20th century technology, argues strongly against dismissing the map as medieval speculation. The Orontius Phineus map of 1531 provides another depiction of Antarctica that shows the continent as a separate landmass with accurate proportions and geographical features. The map includes interior details such as mountain ranges and river systems that match the subglacial topography revealed by modern ice-penetrating radar surveys. The accuracy of these interior features suggests that the original cartographers had access to the continent during a period when it was not covered by ice or possessed survey techniques capable of determining topography beneath ice sheets. The mathematical precision of the continent's outline and the correct placement of major geographical features indicate systematic cartographic survey rather than artistic imagination. The Mercator map of 1569 shows Antarctica divided by waterways that correspond to subglacial channels discovered by modern Antarctic research. These channels, hidden beneath kilometers of ice, form natural boundaries that divide the continent into distinct geographical regions. The map's depiction of these features indicates that its creators possessed knowledge of Antarctic geography that would not be officially rediscovered until satellite surveys in the late 20th century revealed the bedrock topography beneath the ice sheet. The precision of these details and their correlation with features invisible from the surface argues for either ancient exploration during ice-free periods or advanced survey technologies unknown to conventional history. The Boachi map of 1754 depicts Antarctica as two separate landmasses divided by a waterway that corresponds to the subglacial transantarctic mountains. This geographical feature, which divides the continent into East and West Antarctica, was not officially recognized until geophysical surveys in the 1950s revealed the bedrock topography beneath the ice sheet. The map's accuracy in depicting this hidden geographical feature suggests access to source materials based on ancient exploration of the continent or possession of survey techniques capable of determining subglacial topography. The consistency of Antarctic depictions across multiple maps from different periods and cartographers indicates preservation of geographical knowledge from much earlier sources. Analysis of projection systems used in these ancient maps reveals sophisticated mathematical techniques for converting spherical coordinates to flat map representations. Some maps employ projection methods that were not officially developed until centuries after the maps were compiled, suggesting that medieval cartographers possessed advanced mathematical knowledge or copied projection systems from much older source materials. The accuracy of these projections in depicting continental coastlines with correct shapes and proportions indicates systematic survey programs and mathematical tools comparable to modern cartographic techniques. The mystery schools of ancient Egypt represent perhaps the most sophisticated system for preserving and transmitting advanced knowledge across millennia. The Temple of Edfu contains inscriptions describing the builder texts, ancient records that supposedly documented the construction techniques and astronomical knowledge used by the original inhabitants of Egypt called the followers of Horus. These texts, carved into temple walls during the Ptolemaic period, claim to preserve information from the first time. When divine beings established the foundations of Egyptian civilization following a great catastrophe, the Edfu texts describe the reconstruction of sacred sites according to ancient plans preserved from before the flood, including detailed specifications for temple orientations, proportions, and ritual functions. The inscriptions reference sacred mounds where the original knowledge was preserved, describing underground chambers containing scrolls and artifacts from the previous civilization. These chambers, according to the texts, were sealed and hidden to protect their contents from future catastrophes, with access restricted to initiated priests who maintained the ancient traditions. The precision of architectural specifications recorded in these texts demonstrates that they preserve genuine technical information rather than mythological narratives. The priests of Heliopolis developed elaborate initiation systems designed to gradually reveal astronomical and mathematical knowledge to candidates who demonstrated both intellectual capability and moral character. The initiation process required decades of study, beginning with basic mathematics and astronomy, before progressing to advanced calculations involving precessional cycles and stellar alignments. Initiates learned to use sophisticated instruments for astronomical observation, including devices for measuring stellar positions and calculating eclipse cycles that would not be matched by European astronomy until the Renaissance. The systematic curriculum and rigorous testing procedures indicate that Egyptian mystery schools operated as genuine educational institutions rather than religious cults. The temple schools taught what they called sacred science, a unified system that combined astronomy, mathematics, architecture, medicine, and spiritual development into a comprehensive understanding of cosmic order. This knowledge was encoded in temple architecture, with building proportions and decorative elements serving as three-dimensional textbooks that preserved mathematical relationships and astronomical data. The Great Pyramid's internal chambers contain shafts aligned with specific stars that would have been visible at different epochs, creating a stellar calendar that tracks precessional changes across thousands of years. The integration of astronomical knowledge into permanent architectural features ensured that essential information would survive cultural disruptions and political changes. Egyptian medical papyri reveal surgical techniques and pharmaceutical knowledge that demonstrate sophisticated understanding of human anatomy and biochemistry. The Edwin Smith Papyrus describes brain surgery procedures, including trepanation techniques that show knowledge of cranial anatomy and sterile surgical methods. The Ebers Papyrus contains over 700 medical prescriptions using plant and mineral compounds that modern pharmacology recognizes as effective treatments for the conditions they were intended to address. The sophistication of these medical texts indicates that Egyptian physicians conducted systematic anatomical studies based on dissection and experimentation rather than relying solely on theoretical knowledge. The preservation of medical knowledge through temple schools indicates that Egyptian priests maintained detailed anatomical studies based on systematic investigation. The mummification process provided opportunities for studying internal organ structure and function, leading to medical knowledge that was far more advanced than typically attributed to ancient civilizations. Temple inscriptions reference houses of life, institutions where this medical research was conducted, describing them as centers of learning that combined practical training with theoretical study. Archaeological evidence from temple complexes reveals specialized chambers equipped for medical instruction, including facilities for anatomical demonstration and pharmaceutical preparation. The Eleusinian mysteries of ancient Greece represent another sophisticated system for preserving and transmitting ancient knowledge, though their focus emphasized spiritual development rather than technical knowledge. The mysteries were conducted at Eleusis near Athens for nearly 2,000 years, from approximately 1450 BC to 392 AD, making them one of the longest-running educational institutions in human history. The rituals were designed to provide initiates with direct experience of spiritual realities that complemented the intellectual knowledge preserved in other mystery school traditions. The sustained operation of these mysteries across multiple political and cultural transitions demonstrates sophisticated institutional structures and effective knowledge transmission systems. The genetic studies of ancient populations have revealed patterns of migration and cultural contact that support the textual evidence for knowledge transmission between ancient civilizations. DNA analysis of remains from early Mesopotamian, Egyptian, and Indus Valley sites shows genetic markers that indicate sustained contact between these populations, despite the vast distances separating their territories. These genetic patterns correspond to the periods when advanced technological knowledge appears simultaneously in multiple regions. Analysis conducted by the German Mummy Project has identified genetic markers in pre-dynastic Egyptian remains that are more closely related to populations from the ancient Near East than to indigenous African groups. These genetic patterns suggest population movements or direct intervention that introduced foreign genetic material into the Nile Valley during the pre-dynastic period. The timing of these genetic changes corresponds with the sudden appearance of advanced construction techniques, astronomical knowledge, and administrative systems that characterize early Egyptian civilization, suggesting that technological advancement was accompanied by population contact or migration. Genetic studies of remains from Harappan sites in the Indus Valley reveal population structure that includes components from Mesopotamian, Persian, and Central Asian sources. The diversity of genetic lineages represented at these sites indicates that the Indus Valley civilization incorporated populations from multiple geographical origins. The correlation between genetic diversity and technological sophistication suggests that cultural contact and population mixing contributed to the development of advanced capabilities. The timing of increased genetic diversity at Indus Valley sites corresponds with periods of architectural innovation and the appearance of writing systems supporting models of knowledge transmission through population contact. Ancient DNA extracted from remains at Göbekli Tepe and other Anatolian sites reveals genetic continuity between Neolithic populations and later civilizations throughout the Near East and Mediterranean regions. This genetic continuity suggests that populations maintaining advanced knowledge systems persisted across millennia, transmitting technological capabilities through cultural rather than genetic mechanisms. The presence of specific genetic markers associated with cognitive capabilities in these ancient populations indicates selection pressures or founder effects that concentrated certain traits within groups responsible for preserving and transmitting complex knowledge systems. Mitochondrial DNA analysis of royal mummies from ancient Egypt reveals maternal lineages that differ from general population patterns, suggesting that ruling families maintain distinct genetic heritage across multiple dynasties. The genetic markers found in royal remains show greater similarity to Near Eastern populations than to general Egyptian populations, supporting historical accounts of foreign origins for some ruling dynasties. The preservation of distinct genetic lineages within ruling families across centuries indicates systematic marriage practices designed to maintain specific hereditary characteristics, possibly including traits associated with intellectual capabilities or cultural knowledge. Y chromosome analysis of ancient Mesopotamian remains reveals paternal lineages that show long-distance connections between geographically separated populations. Specific haplogroups appear at sites spanning from Anatolia to the Indus Valley, indicating male-mediated gene flow across vast distances during periods corresponding to the development of urban civilizations. The distribution patterns of these genetic markers suggest organized long-distance movement rather than gradual diffusion, supporting models of systematic knowledge transmission through trained specialists who traveled between cultural centers. The pattern of 7 civilizations described in various ancient traditions aligns with geological and astronomical evidence, indicating that major catastrophic events occur at regular intervals throughout Earth's history. The 12,000-year cycle that appears in flood traditions worldwide corresponds to half-precessional periods, when the solar system's position relative to galactic influences creates conditions conducive to environmental instability and cosmic impacts. Modern space science has identified potential sources of cyclical catastrophes, including comet swarms associated with the solar system's oscillation through the galactic plane. The galactic year, the period required for the solar system to complete one orbit around the galactic centre, lasts approximately 225 million years. During this orbit, the solar system oscillates above and below the galactic plane, with a period of approximately 64 million years. This oscillation brings the solar system through regions of varying cosmic ray intensity, gravitational influences, and comet density that could trigger periodic catastrophic events on Earth. Analysis of impact crater dating reveals clustering that corresponds to this oscillation period, suggesting that cosmic impact frequency varies systematically with the solar system's galactic position. The Taurid meteor stream, associated with Comet Encke, contains fragments that represent potential impact hazards during periods when Earth's orbit intersects dense portions of the debris field. Astronomer Victor Klube has proposed that this stream contains large objects capable of causing regional or global catastrophes during close encounters. The Taurid stream's orbital characteristics create intersection periods that recur at intervals corresponding to historical catastrophe periods, including the Younger Dryas event. The persistence of this debris stream and its regular intersection with Earth's orbit provides a mechanism for recurring impact events at predictable intervals. Ice core data from both Greenland and Antarctica reveal multiple rapid climate transitions occurring at approximately 11,000 to 12,000 year intervals throughout the past 100,000 years. These climate shifts show similar characteristics, including abrupt temperature changes, increased atmospheric dust, and geochemical anomalies consistent with cosmic impact events. The regularity of these transitions suggests systematic forcing mechanisms rather than random climate variability. The correlation between climate shifts and geological evidence of impact events supports models of cyclical catastrophism driven by astronomical factors. Analysis of sediment cores from ocean basins reveals periodic layers of disrupted material containing impact markers including shocked minerals, carbon spherules, and extraterrestrial material. The spacing of these layers corresponds to intervals of approximately 12,000 years, matching the cycle length described in flood traditions and observed in ice core climate data. The global distribution of these impact marker layers indicates that the catastrophic events affected multiple regions simultaneously, supporting accounts of worldwide floods and environmental destruction preserved in ancient texts and oral traditions. The mathematical precision with which ancient civilizations calculated and predicted these cycles demonstrates that prehistoric cultures possessed sophisticated astronomical knowledge and recognized patterns of recurring catastrophic events. The encoding of cycle lengths in architectural monuments, calendar systems, and mythological narratives indicates systematic efforts to preserve this knowledge for future generations. The consistency of these encoded warnings across geographically separated cultures suggests either common origins or recognition of genuine periodic threats that multiple civilizations independently observed and documented. Understanding these cyclical patterns and the ancient knowledge systems that tracked them may provide crucial insights for recognizing and preparing for future catastrophic events that could threaten contemporary civilization. The evidence presented throughout this investigation points to a profound truth that challenges conventional understanding of human history and development. We are not the first advanced civilization to emerge on Earth, but rather inheritors of knowledge systems that have been carefully preserved through multiple cycles of catastrophic destruction and cultural renewal. The precision of astronomical calculations encoded in ancient monuments, the sophistication of metallurgical techniques preserved in artifacts that predate their supposed invention by millennia, and the global distribution of flood narratives containing identical technical details all converge on a single unavoidable conclusion. Human civilization has experienced periods of remarkable advancement, followed by catastrophic collapse, with survivors preserving fragments of their knowledge through carefully designed institutional structures that could transmit essential information across dark ages lasting thousands of years. The mathematical relationships embedded in structures like the Great Pyramid, Stonehenge, and Angkor Wat demonstrate understanding of precessional mechanics, planetary dimensions, and cosmic cycles that required continuous astronomical observation programs maintained across multiple generations. The consistency of these encoded constants across cultures, separated by vast distances and time periods, indicates they derive from common sources rather than independent discovery. The mystery schools of Egypt, the Eleusinian traditions of Greece, and the priestly lineages of Mesopotamia represent sophisticated systems specifically designed to preserve this accumulated knowledge through periods of social collapse and cultural transformation. The geological evidence for the Younger Dryas impact event, corroborated by the worldwide distribution of flood traditions containing matching technical specifications and chronological markers, confirms that approximately 12,900 years ago, human civilization experienced a catastrophic reset that destroyed advanced cultures and forced survivors to rebuild from drastically reduced circumstances. The underwater ruins at sites like Dwarka and Yonaguni, the precision megalithic construction at Pumapunku and Sacsayhuaman, and the advanced astronomical knowledge preserved in Sumerian cuneiform tablets all point toward pre-Diluvian civilizations that achieved technological capabilities rivaling or exceeding those of later historical periods. The cyclical nature of these catastrophic events, recurring at intervals corresponding to astronomical cycles that ancient civilizations carefully tracked and encoded in their calendrical systems, suggests that human development follows patterns of rise and fall driven by cosmic forces beyond human control. The recognition of these patterns by prehistoric cultures, demonstrated through their systematic efforts to preserve knowledge and warn future generations, indicates that ancient peoples understood their place within much longer temporal frameworks than conventional history acknowledges. As we stand at the threshold of capabilities that could either elevate humanity to unprecedented heights or precipitate another civilizational collapse, the lessons preserved in these ancient knowledge systems become crucial for our survival and evolution. The warnings encoded in monuments, texts, and traditions spanning millennia remind us that technological advancement without wisdom leads to catastrophe, and that the true measure of civilization lies not in its achievements, but in its ability to preserve essential knowledge for those who will rebuild after the inevitable cycles of destruction that periodically reset human development on this ancient and ever-changing planet.